A&B coefficients will study from the emission, the basic of laser. So that day only a little bit explanation only we gave on laser, that is a light amplification by stimulated emission of radiation. Okay, this using the concept of laser and concept of light, we derived the equations, and that equation contains the two constant terms A and B, and this coefficient, we will read what is the name of this A and B, are called as the Einstein coefficients. To find this Einstein coefficients, definitely you should have the knowledge about what is by absorption, what is in by spontaneous emission and stimulated emission. So we all know light can refract and absorbed. Okay, light when it falls on any object, it absorbed and also it emitted. We all know in our lower classes we have studied. During summer we cannot wear the dark color, that is the black color dresses. What is the reason? And we cannot use the black color umbrella. What is the reason? What is the reason of this condition? You should not wear that. Huh?
It absorbs more.
It absorbs more radiation. Light and normal light. This is not a normal room light. This is the radiation from the sun. So the dark colors will absorb the maximum light radiation towards it. So light will be absorbed and also emitted. What is the meaning of emission? Emission means? The simple meaning of emission. Releases, that's all. Releasing. Emission na absorbன்றது ஒரு input na emissionன்றது output, that's all. Absorb பண்ணி release பண்ணுது. Absorption and emission. Okay, now we'll come and see this. What is the meaning of absorption here? So that day itself we have seen on the basic. Before you are passing any energy, if you take the bulb, ordinary bulb, we'll go from the principle of ordinary light. We all know the source of the bulb, and the gundu bulb irukla adula source enna use pandrona, tungsten filament. Am I correct? Your tube light contains the filled with gases used as a medium. Here in this bulb we used tungsten as a medium. Okay, before I switched on the switch, before I pass the current to the tungsten filament, what about the tungsten atoms? You can see a small thin filament of tungsten on the bulb, and the thin tungsten filament, you know, it has a large number of atoms. All are tungsten atoms only. So before you are passing any energy to that tungsten filament, what about the position of the tungsten atoms? Does it excited mode or in the rest ground state mode?
Rest ground state mode.
Yes, rest. All the atoms, copper wire, the same thing. If you are passing, before you are passing the current to any devices, electrical fan, electrical light, fridge, any devices you are passing, before you are passing, all the devices are in the rest mode. The meaning is that the atoms are used for the gas medium or a solid medium, and the medium uடைய atoms are in the ground state. So that is the level. You take the level as E1, lower energy state E1. Why we are dividing like this means we have to imagine all these things. We can explain only with the imagination only. So before I passing the current, before I am passing any energy to this tungsten filament, all the atoms are in the ground state. Tungsten atoms. These are all the tungsten atoms. The tungsten atoms are in the ground state. Now, when I pass the energy, suppose light energy or electrical energy. Electrical energy na E power minus potuko, electrons hit. This H nu. If you are giving any energy to this atom, now you are switch on the current. When I switch on the switchboard, when the board is on, that now the electrons will passes through the wire, reaches the tungsten atom. The tungsten atom gains the energy from the electron and it excites. That is the state, absorption. So the tungsten atom gains. Gaining means absorbing. The tungsten atom absorbs the energy from the incident particle, even it is an electron or some photons, anything. ஏதோ ஒரு சோர்ஸ், டெம்பரேச்சர் கொடுக்கலாம், லைட் பாஸ் பண்ணலாம், or you can pass the electricity. These atoms or gains the energy, absorbs the energy and excited. We call this process as absorption. So what happens? The tungsten atom, before you are passing current, supplying the current to this tungsten atoms, the atoms are in the ground state. When I started to pass the energy, atoms in the ground state are absorb the energy and excited, goes to the level E2. Because depends upon the energy you supplied, these atoms can jump to the fourth level also, E1, E2, E3, E4. We call it as a solid, 4-level solid state laser. So it does not restrict itself to E2. These atoms will jump to level E2, higher energy state. Just for explanation, here we are using only the 2 levels. So the atoms jump from level E1 to higher energy level E2 by absorbing energy. We call it as the process absorption. Now we are going to write the equation for this absorption. Okay.